Hi everyone, welcome to our second lesson in chapter 8 on how do we find the surface area of a rectangular prism. If you'd like to pause the video to give the do now a try, now would be the time to do so. Alright, the do now says, which of the following figures would represent an unfolded tissue box? What I have here to try and explain this is a tissue box. So if we were to unfold all of the pieces of this tissue box, the question is, what would it look like? Now, I'm not actually going to do so here just because the flaps of the sides here will make this not look exactly like the picture. But let's just talk about what would happen here if I unfolded this tissue box. So let's first talk about how many sides there are. So we have the top of the tissue box, the bottom, that's two sides. The two sides of our tissue box is where Woody is, 1 and 2. So that's 4 total so far. 1, 2, 3, 4. And then there's 2 more faces, the sides. 1, 2, to make a total of 6. 1, 2, 3, 4, 5, and 6. So in our picture, we're looking for 6 faces. Option 1 has 1, 2, 3, 4, 5. No good. Option 2 has 1, 2, 3, 4, 5, 6. Looking good to me. That is our answer, and we know that that's our answer because each of these 6 faces are all rectangles. Rectangle, rectangle. As are all of the faces in the net, as we are going to call them, that I just labeled. Number 3 certainly does not make any sense. There are no triangular faces as I unravel a tissue box. Same thing with number 1, no triangles. All right, our notes for today. We're going to skip over the investigation for now because I had a tissue box and was able to show you the different faces of it. So we're going to jump right to our notes. Surface area of a rectangular prism. Our first method for how we do this is to draw what I had referenced in the do now, something called a net. Each of these are called nets. We use the net to find the area of each base and each face. And then we add all of the areas together to find the surface area. So if you can see in this picture here, we have a net with 2 bases and 4 faces. Now that's a specific way of describing all of the faces of a 3D figure. The difference between a face and a base is a little bit confusing. Earlier, I had mentioned that in the tissue box example that this tissue box has 6 faces. It certainly does. But we can specifically, if we want, call 2 of these faces bases. In the case of the tissue box, we have 2 bases, the top and the bottom. Base is something that the 3-dimensional figure can sit on. Obviously, in a tissue box example, the front or the top would never be the side that we sit the tissue box on because then we wouldn't be able to get the tissues out of it. But mathematically speaking, both of these are still considered our bases. But what you really should focus on is the fact that 3-dimensional figures have faces and a rectangular prism has 6 of them. The second method for finding the surface area of a rectangular prism is using this formula, which is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. A little bit of a confusing formula, a little lengthy. Don't necessarily expect you to memorize that because you can always use method number 1, but that works too. So I hope in going through some of this stuff, you have an understanding of how we find the surface area of a rectangular prism. But to conclude, what we want you to take away from this is if you have a rectangular prism, like a tissue box, and you want to find the surface area of it, when you think of the word surface, surface is all of the area around a three-dimensional object. For example, if I wanted to wrap up this tissue box, I would need a certain amount of paper. So that amount of paper that I would need to wrap each of the faces of this box represents what we call surface area. So that's why we really like method number 1 of finding the surface area. Because if we can break down a 3D object into its net, we're able to see how many and what each of the shapes are that make up a three-dimensional object. And if we're able to find the area of each of those different faces, we will know the total surface area. All right, time to try this together. So we're going to find the surface area of this three-dimensional rectangular prism right here. To do so, we're going to find the area of each base and each face. And I'm going to label what each of these are right now. So we're going to do 6 different areas here because we know that rectangular prisms have 6 different faces. The top, like the top of our tissue box, the bottom, and we're labeling these to keep nice and organized. The front, the back, the left, and the right. The top being this face here, the bottom being the bottom, the front being the one that's looking right at us, the back being here, the left being this face, and the right being this face. Total of 6. So we're going to find the area of each of those faces. Now, each of these shapes that I just outlined, they are all rectangles. And we know the area of a rectangle is length times width. So let's find the area of the top rectangle first, up here. Now that rectangle does not have any dimensions, but we know what its dimensions are because if this length is 2.5, this one must also be 2.5 because it's a rectangle. We know opposite sides of a rectangle have the same length. Now the width of this rectangle, if this is 3.5, then this must be 3.5. That is the length and width of that top rectangle. So 2.5 times 3.5 make 2 1/2 times 3 1/2, 8 3/4 feet. And we're talking about an area here, so it's square units. Now that's just the area of the top. Time for the bottom. The bottom is the same exact rectangle as the top. Just like our tissue box, this rectangular shape is exactly the same as the one on the bottom. So we don't have to do this work out because it's the same as the top. We know the area equals 8 3/4 feet squared. Now let's find the area of the front. Another rectangle, length times width. This one's a little simpler because we have the labels right here for us. The area equals length, 3.5, times the width, 1.5. Now just keep in mind, I don't want to confuse you. Some people may be thinking, wait, why isn't this considered a height? Well, yes, the height of this rectangular prism is 1.5, But right now, we're just talking about the area of this rectangular face. And this rectangular face is a two-dimensional shape. 2D shapes do not have heights. It's just a length and a width. So 3.5 times 1.5. Sorry, 1 1/2 is 5 1/4. Same thing as we did before, we don't need to find the area of the back because it's the same as front. So we know the area of the back face is 5 1/4 feet squared. Last two faces, the left. So let's find the area of the left face rectangle. The length of this rectangle here, we need to figure out. Remember, these faces over here on the left and right are the same. So if this amount is 2.5, so is this. So the area of this face is a length of 2.5 times a width of 1.5. And 2 1/2 times 1 1/2 is 3 3/4 feet squared. The right face is the same as the left, just like this face is the same as this. So same as left. Area equals 3 3/4 feet squared. Now, before I continue, if any of this is confusing you with the faces, I highly suggest at home, go grab a tissue box. You may not have a rectangular one like this, but you may have a cube-looking tissue box, or really any rectangular prism figure. They're definitely all over your house. You may have a box with a board game in it or a puzzle. Any sort of rectangular figure, it would be helpful to hold it in your hands and look at it to see the different faces. What I have here is a little puzzle box. Rectangular prism, same deal. It's got 6 faces: top, bottom, front, back, left, right. All rectangles. This makes a rectangular prism, and we can find the surface area of it. So I definitely suggest finding your own rectangular prism just so you can visualize what we've been talking about. We're going to move on with letter B. Find the surface area by adding the areas of the bases and faces. So to find the total surface area, we need to add all of the areas that we just found of each of the individual faces. So I'm going to add 8 3/4 plus 8 3/4 plus 5 1/4 plus 5 1/4 plus 3 3/4 plus 3 3/4. When I add all of these up in my calculator, 8 3/4 plus 8 3/4 plus 5 1/4 plus 5 1/4 plus 3 3/4 plus 3 3/4. We get a total of 35.5 feet squared. That is our surface area. We abbreviate with SA, 35.5 feet squared. And this is using method 1. Find the surface area using the formula. Now, I know this may have seemed very busy, but it's very visual. If you want to use that formula, method number 2, I showed you here. That formula is surface area equals 2LW plus 2LH plus 2WH. So we're going to substitute in some values here. It may be helpful to you on the side to write down what the width, length, and height are of this three-dimensional object. We know that the length of this object is 3.5. We know that the width of this object is 2.5, and the height is 1.5. So it's really important that you organize yourself and write down the width, length, and height off to the side so you don't get mixed up when you're plugging the values or substituting your values into the formula. Now we're just going to plug in those values. The length is 3.5 times the width, 2.5, plus 2 times the length again, that's 3.5, times the height, that's 1.5, plus 2 times the width again, that's 2.5, times the height, 1.5. Really have to make sure you're organized, you don't miss anything. This is a very long string of mathematical operations and numbers that we're combining together. Now, I'm going to use the calculator to do this one at a time, just so I don't confuse myself. I'm going to do 2 times 3.5 times 2.5. I'm just doing this first piece to get 17.5. Can write it as a decimal if I want. Plus, remember that was just this part. Now I'm going to do this second piece. 2 times 3.5 times 1.5. I get 10.5 or 10.5. Plus, let's do the third piece. 2 times 2.5 times 1.5. 7.5 or 7.5. What's that? So our surface area equals 17.5 plus 10.5 plus 7.5. So if I add all these up, 17.5 plus 10.5 plus 7.5, we should know what our answer is because we just did it earlier. Let's see, 35.5. 35.5 feet squared. The answers match. Because both methods work, we should get the same answer. Last question, D. Find the volume of this rectangular prism. We learned how to find volume of rectangular prisms in the last lesson, so this should be fairly straightforward. Volume equals length times width times height. We know the length, we're nice and organized over here, 3.5 times a width of 2.5 times a height of 1.5. When I use my calculator, 3.1/2 times 2.1/2 times 1.1/2, we get a volume of 13.1/8 cubic feet, because we're back to volume, cubic feet. Awesome. Time for you to try. If you'd like to pause the video, I would suggest doing so, trying this question on your own. Put your best foot forward, give it a try, then check back in to get the answer from me. All right, so number 2, find the area of each base and each face. We're going to find the surface area of this rectangular prism using method 1. So I'm going to be nice and organized and label, just like I did in the Let's Try Together example, which area I'm doing in which organized box here. So we have the top, bottom, front, back, left, and right. So the top of this rectangular prism, that's this right here, which is the same as the bottom. So we know that this face has a length of 3.7, the same as down here, and a width of 4.1. the same as down here on the bottom. So the area of this top face, it's a 2D figure, length times width, area equals 3.7 times 4.1. And 3.7 times 4.1 is 15.17 centimeters squared. The bottom face is the same as the top. So the area equals 15.17 square centimeters. Time for the front. This front face has just writing my area formula, has a length of 3.7 and a width, that amount is the same as this dimension, 10, a width of 10. Remember, length and width are interchangeable. If you thought that the length was 10 and the width was 3.7, that works just fine. 3.7 times 10 is 37 square centimeters. The back of this rectangular prism is the same as the front. So we know the area equals 37 square centimeters. Time for our last pair of faces, the left and the right. And if you want, I'm just looking at this figure. To me, it's easier to visualize the right face. So I'm going to do that box first. The area of this right face is a length of 4.1 and a width of 10. 4.1 times 10 is 41 square centimeters. And we know that this left face is going to be the same as the right. So the area equals 41 square centimeters. So our total surface area, that's what we're going for here. The total surface area is adding up all of these faces together. 15.17 plus 15.17 plus 37 plus 37 plus 41 plus 41. When I add all of those up, 15.17 plus 15.17 plus 37 plus 37 plus 41 plus 41, I get 186.34 centimeters squared. That is my surface area. Good, let's move on to the back. We're going to find the surface area of this same prism using our formula. So I'm going to actually bring this over here so we can see as a reference. Let's write down our formula first. Surface area equals 2LW plus 2LH plus 2WH. And I want to keep nice and organized, so I'm going to make sure I write down my length, width, and height on the side here. I know I did it in a different order in the previous question. I did WLH. You can use LWH too. It doesn't really matter, as long as we stay organized. The length of this rectangular prism, like I said, it doesn't matter what we choose, but I'm going to choose my length to be 3.7, the width to be 4.1, and the height to be 10. So let's plug in our missing values here for the surface area. We're just substituting very carefully. 2 times the length, which is 3.7, times the width, which is 4.1, plus 2 times the length, which is 3.7, times the height, which is 10, plus 2 times the width, which is 4.1, times the height, which is 10. Be nice and organized with your multiplying. I know that I'm using the dot here to represent multiplication, and there's some decimals too. Just make sure you're being very neat with your with your writing down of your multiplication dots. If you want to keep organized in a different way, feel free. You can always write down 2 times 3.7 times 4.1 in parentheses if you're worried that you're going to mistake a decimal point for a multiplication symbol. So that's just me writing that down in another way right there. So let's figure out this surface area. I'm going to do it in 3 separate steps. 2 times 3.7 times 4.1 is 30.34 plus 2 times 3.7 times 10, that's 74, plus 2 times 4.1 times 10, that's 82. And when I add each of those 3 up, 30.34 plus 74 plus 82, I get a total of 186.34. 186.34 cubic centimeters. We know we did it right. It matches up perfectly. Last letter, letter D. Find the volume. Volume of this prism, length times width times height. We're nice and organized, so this should be quick and easy. Length, 3.7, times the width, 4.1, times the height, 10. I'm going to use my calculator to multiply these 3 together. 3.7 times 4.1 times 10. I get 151.7 cubic centimeters, because it's a volume. Alrighty. To summarize, compare and contrast surface area and volume. I'm going to write 2 different sentences here to summarize what we learned today. Surface area measures the outside of a 3D figure, while volume measures the inside of a 3D figure. And that's a really important fact, understanding the difference between surface area and volume. I'll repeat it once more. Surface area talks about that outside area of a 3D figure. Think about wrapping a present. And volume measures the amount of space that occupies the inside of a 3D figure. All right, I hope you enjoyed the video. Please feel free to ask any questions if you have them. You know how to contact us. Have a wonderful day and rest of your week.